This problem is going to be dealing with probabilities based on areas. In a sporting event, the scoring area, shown here, consists of 4 concentric circles on the ice with radii of 3 inches, 3 feet, 6 feet, and 7 feet. If a team member lands a 43-pound stone randomly within a scoring area, find the probability that it ends up centered on the given color. A, red, B, white, C, blue. Okay, so in this particular problem, since we're dealing with concentric circles, we are also dealing with these colored rings that is going to be important to find the area of each of the rings. We're given the radius of each concentric circle. We'll find the area first of each concentric circle, and then we will subtract smaller concentric circles from the larger concentric circle to get the area of the ring. Okay, to find the areas of each of the concentric circles, we're going to start from the inside and we're going to work our way out. And remember, we're going to have a center point in the circle, and that's what we're going to use to determine what the area of each of the concentric circles is. For example, our first concentric circle has a radius of 3 inches. Now let's address that for a moment, because the rest of the radii are given in terms of feet. We need to make sure that our units are the same. And since 3 of the measurements are in feet and 1 of the measurements in inches, we're going to convert the measurement in inches to feet first. So 3 inches is going to be the same as, and what we're going to do is, we know that there are 12 inches in a foot, so we're going to use our conversion factor, 1 foot over 12 inches. Notice that the units will divide out. Inches will divide into inches, and I don't have to worry about them anymore, which means that my resultant value will be in feet. So then 3 times 1 over 12 is 3 over 12, which is going to simplify to 1 over 4. So this is going to be 1/4 of a foot. And so when I look at this inner circle, I know that the radius, R, is equal to 1/4 feet. Now remember that you've got to know the formula for area of a circle. It's easy to look up, but the area is equal to the value of pi times the radius squared. So what we're going to do is go ahead and start and find the areas of each of the concentric circles now that I have everything in terms of feet. I know that the radius of this blue circle is going to be 3 feet. I know that the radius of this larger white circle is going to be 6 feet. And I also note that the radius of the larger circle with the red ring on the outside is going to be 7 feet. And so we're going to go ahead and find the area of each one of these. So what I'm going to do is I'm going to say the area, and I'm going to use a subscript. And this way I'm going to indicate which radius I'm using. So this is going to be the area of the circle that has a radius of 1/4 feet. And that's simply going to be equal to pi times 1 over 4 squared, which will be equal to pi over 16. Do not convert this to a decimal equivalent. Leave it as pi over 16 for right now. We're going to do that with all of our concentric circles, because as we work through this, we'll find out that the pi values will divide out and we won't have to deal with them. So now let's find the area of the circle that has a 3-foot radius. That will be equal to pi times 3 squared, and that's equal to 9 pi. And then we'll find the area of the circle with a 6-foot radius, and that will be equal to pi times 6 squared, which will be equal to 36 pi. And then the area of the circle with a 7-foot radius is going to be equal to pi times 7 squared, which is equal to 49 pi. Now, keep in mind that since all of our measurements are now in feet, our area is actually in square feet. Once again, though, that in the long run is not going to be important as far as carrying through on our calculations, because those units will divide out. And we'll talk about that in a moment. So now our second step is going to be finding the area of the rings. The red ring, the large white ring, the blue ring, and then of course we already have the area of the inner circle, so we're not going to have to do that again. But we are going to have to use our areas that we found for the concentric circles to determine the areas of our rings. Okay, so first we're going to find the area of the red ring. So I'm going to write that as area sub R, meaning red ring. And what I need to do is take the area of the circle that has a radius of 7 feet, which goes all the way out here, and I'm going to subtract the area of the circle that has a radius of 6 feet, and what will be left is the area in the ring. So the area in the red ring is going to be equal to the area of the circle with a 7-foot radius minus the area of the circle with the 6-foot radius. And what that will be equal to is 49 pi minus 36 pi. When I do that subtraction, I will get 13 pi square feet. The next thing that I want to do is get the area of the white ring. And so what I'm actually going to do is to continue differentiating, as I'm going to call this first one the area of the red ring, RR. The area of the white ring, and I'm using that to differentiate between the area of this white ring here and the inner white circle. So now what I'm going to do is erase my markings for the area of the red ring. Notice that I've actually increased the size of the diagram so that it'll be easier for you to follow everything that I'm doing. But the area of the white ring is going to be taking the area of the circle that has a 6-foot radius and subtracting the area of the circle that has a 3-foot radius. And that will give me the area of the white ring. So we'll say a sub 6 minus a sub 5, and that will be equal to 36 pi minus 9 pi. And this is going to be equal to 27 pi square feet. Now, that's the area of the white ring. The next thing that I want to do is find the area of the blue ring. The area of the blue ring, if you're following along, is going to be And let me erase my markings. It's going to be the area of the circle right here that has a radius of 3 feet. And we're going to subtract the area of the circle that has a radius of 1/4 foot. I don't know if you can see the 1 there. There we go. And so it's going to be the area sub 3 minus area sub 1/4 will be equal to 9 pi minus pi over 16. Now, keep in mind that when I'm doing this, I want to try to keep this in terms of pi. And depending on the calculator that you have, you may be able to actually input pi in there and get your answer. But in reality, what this is just simply 9 minus 1/16. And so when I calculate that, if I'm using a calculator that will display it as a fraction, I will get 143 over 16. And so my answer here is 143 over 16 times pi square feet. I want to try to keep it in decimal format. Now, it depends on the calculator. And I recommend a Casio FX115 ES Plus. And I do have an emulator for that calculator right here, so I can show you what I'm doing when I calculate this. I enter 9. I'm going to subtract the fraction 1 over 16. And then simply press equals, and I get 143 over 16. Likewise, I can actually keep pi in there, because you'll notice where my mouse cursor is down here at the bottom of the keyboard. You'll see this little pi symbol. And so if I want to take 9, I'm going to press shift, and then I will press this button, and I get 9 pi. Now I'm going to subtract the pi over 16, which is a fraction. I'll use the same shift and then this bottom key and get pi. Then I'm going to move down into the denominator, type in my 16, press enter, and it gives it to me as a true display. Now, yes, I can convert it to a decimal if I press this SD key, but that's not going to keep me as accurate as I want to be. I want to wait until the very end of my calculations to do any conversions from these accurate measurements to these decimal equivalents. Okay, so now that I've found the areas of the concentric circles and use that to find the areas of the rings, I now can go ahead and find my probabilities. The first probability that we want to do is the red ring. Well, what does that mean? So we're going to go ahead and use the probability formula, and remembering that P of E, the probability of the event, is going to be equal to N of E, which is the number of favorable outcomes, over N of S, which is the number of outcomes in the sample space. Now, the thing is we're using area here instead of actual outcomes, as far as, like, for example, if we were drawing a card from a deck of cards and say that what's the probability of drawing the Jack of Hearts, that would be 1 over 52, because there's 52 cards, but there's only one event. In this case, we're going to use area. So the probability of the event is going to be equal to the area of the event divided by the area of the entire circle. And no, this is not traditional notation, but it works for our problem. So let's talk about A, which is going to be finding the probability of the stone landing in the red ring. So what we're going to do is we're going to take the area of the red ring, which we've already calculated. We did that right here. And that's going to be 13 pi. We're not going to worry about the square feet because that would divide out. But we could put that if we wanted to. And I'll just do that just to show you how it divides out. And that's going to be over the area of the circle, which we've already calculated, which was right here. And that's going to be 49 square feet, or 49 pi square feet. Now notice a couple of things here. First off, we'll divide out the units because the probability is going to be unitless. We also can divide out the pi, and then we're going to be left with the probability of 13 over 49. Now, obviously, we can go ahead and convert that to a decimal, and 13 divided by 49 is going to give us the following. And I'm only going to carry it out 6 decimal places, 265,306. So you can either use it as a fraction or a decimal. Now let's talk about the probability of the blue region before we do the probability of the white region. And so that was part C. So the probability of blue is simply going to be equal to the area of the blue region, or blue ring, which we found right here. And that's going to be 143 over 16 pi square feet. And that's going to be over the entire area of the circle, which was 49 pi square feet. Once again, in this case, the square feet will divide out. Likewise, so will the pi. And then we'll be left with 143 over 16 over 49, which is the same thing as saying the fraction of 143 over 16 divided by 49, which is going to give us the following fraction, which is 143 over 784. And we can go ahead and convert that to an approximate decimal amount, and we'll go 6 decimal places once again, and it'll be 0.182398 rounded. All right, now what we're going to do is look at the white regions, because there are 2 regions there, whether it's going to land in the white ring or in the center circle part. And so we're going to have to combine this and determine our probabilities from those 2 calculations. So we have the probability of the white region being equal to the probability of landing in the white ring plus the probability of landing in the center. Remember, these are the 2 areas that we're talking about. And so we're going to need our information as far as how do we establish this. So the probability of the white ring is going to be the area of the white ring. So let me scroll back up so that we can get that. And that's right here. And that's going to be 27 pi square feet. And that's going to be over the total area of the circle, which is 49 pi square feet. So what we'll do is we'll go ahead and do our simplifications here. The units divide out. Pi divides out, and we'll be left with 27 over 49. Now remember, we're going to be adding that to the probability of landing in the center. And so what we're going to need is the area of the center, and that's going to be this area right over here, which was pi over 16 square feet, and then we'll divide that by the total area. So pi over 16 square feet divided by 49 pi square feet. Once again, what we're going to end up doing is simplifying this. The units will divide out and they'll be gone. But now here I've got this pi over 16 divided by 49 pi. And just to make sure that you follow how we're doing this, if we take pi over 16 and divide by 49 pi, that's going to be the same thing as pi over 16 times the reciprocal of 49 pi, which is 1 over 49 pi. And you'll note that in this instance, pi will divide out, and that's 1, and that's 1, which means I have 1 times 1 in the numerator over 16 times 49 in the denominator, which is going to give me 784. And so now I can go ahead and add 1 over 784. And of course I want to go ahead and add these two fractions together. And so 27 over 49 plus the fraction 1 over 784 is going to give me the following fraction of 433 over 784. And we'll go ahead and we'll convert that to a decimal also and round to 6 decimal places, and it's 0.552296.